The next thing we're going to learn about is the gas laws. There are 3 of them, and the first one is called Boyle's Law. Now, we are the gas particles and we're inside a box. Just a regular box, but we're a very, very special gas. We're called an ideal gas. Whee! Listen, boys, we're an ideal gas. Way! But what does that mean? Well, because we're an ideal gas, that means we have to follow special rules. The first rule of Ideal Gas Club is there are lots and lots and lots of particles. The second rule of Gas Club is that when we're bouncing off each other, these collisions are perfectly elastic. Can you remember what that means? It means that there's no energy lost in the collision. The third rule of Gas Club is that when we're bouncing around, the only time we interact with each other is when we hit off each other. There are no forces between us. And the last thing about us, the last law of Gas Club, is that we're very, very small. That means that the box is mostly filled with space. So that's the rules for being in an ideal gas. Whee! Now, the first gas law we're going to learn about is Boyle's Law, or as the French call it, Le Mariotte Law, or something like that. Boyle's Law concerns the gas particles in a box, and I want you to think about us bouncing off the walls and bouncing off each other, but we're going to change something, okay? We're going to change the volume of the container. The temperature is not going to change. That's absolutely certain. The temperature is not going to change. We're going to keep it the same. But we're going to change the volume. Now, you can see it's bouncing around. What do you think will happen if the volume of this container is cut in half? Have a guess. If you guessed that when they cut the volume of the container in half, that the number of collisions doubled, you'd be right. Whee! That's what happens. Look, regular size container, we're bouncing off like this. B, O, E, A. But when you cut the container in 2, look, ooh, E, ooh, E, ooh. It's such a laugh. So as you can see, the pressure and the volume are inversely proportional to each other. When you double one, the other one halves.
You've watched the video on Boyle's Law and the gas rules, and we're going to go over that a little bit. The gas rules are also known as the kinetic molecular theory of gases. The first rule in this kinetic molecular theory is that most of the volume is empty space. So the gas particles take up a very, very small volume. They're very, very little, and they take up a very small volume, and so most of this volume is empty. The second rule in the kinetic molecular theory is that the particles are in random motion, and there are a lot of particles. The third rule is that the collisions between gas particles and their container are completely elastic. That means that no energy is lost or gained when they hit each other or they hit their container. Last rule is that gas particles do not attract one another and they do not repel one another. In other words, there are no forces between them. And that wraps up the kinetic molecular theory of gases, or the kinetic molecular theory rules. Boyle's law is simply P1 V1 is equal to P2 V2, and temperature is constant. P represents pressure, and V represents volume. 1 represents initial, or the beginning pressure or volume, and 2 represents final. I can't spell. Final pressure or volume. So P1 represents initial pressure, V1 represents initial volume, P2 is final pressure, and V2 is final volume. Okay, so now we're going to work a problem with Boyle's law. Our problem is that oxygen gas has an initial pressure of 2 atmospheres and an initial volume of 8 liters. If that final pressure of oxygen changes to 1 atmosphere, what is the final volume of oxygen? Boyle's law, which we're going to use, is P1 V1, that's a 1, not an I, is equal to P2 V2. Now it states here that our initial pressure is 2 atmospheres, so P1 is going to be 2 atmospheres. And we're going to multiply that by our initial volume, which is 8 liters. So multiplied by 8 liters. That is going to equal our final pressure, which happens to be 1 atmosphere. And we're going to multiply that by V2, which is what we're looking for, our final volume. Okay, so we have 2 atmospheres times 8 liters is equal to 1 atmosphere times final volume. We're going to divide each side by 1 atmosphere. When we do that, our atmosphere units cancel, and we end up with 2 times 8, which is 16, and our units are liters, is equal to our final volume. And there you have it. Our final volume is 18 liters. You have now finished this video. I would like for you to go to Skyward, open up the questions, and there are 8 of them, and answer them for a grade. And see you tomorrow.